This video is guidance on Criterion C Strand 3, in which you will produce a detailed plan for the manufacture of your prototype. Your detailed construction plan should include all of the processes, equipment, time, and quality control, as well as risk assessment that you're going to need to think about and plan for production of your prototype. An appropriate construction plan comprises a sequential order of operations to follow to make the prototype. You should include details of the construction of the prototype, from marking out the materials, so that is preparation and any sort of CAD files that you're doing, to final assembly. You should also separate the construction plan by each component, then include an additional section to detail the plan for assembling the product. You should include the following steps. Preparation. So this includes collection of the material, creating templates and any sort of jigs or other quality control aids that you might need. Marking out, including the preparation of computer-aided design, computer-aided manufacturing files, any cutting or machining, any shaping that you might do, any additive manufacturing, so that would be like 3D printing, any finishing, so this could be sanding or painting, any assembly, and any joining that you're planning to do. The construction plan is a planning document. It must be written before the prototype is manufactured. It must not be written retrospectively or after the prototype has been manufactured. And it must not be a diary or a narrative. You can use the research that you did in Criterion B to help you in this process, but you cannot write your construction plan after you've built your prototype. The IB is really making a big point about this. If the construction plan is written retrospectively or after the prototype is completed, the work fails to address the lowest mark band for this criterion. Diaries of manufacture, in addition to the construction plan, are not required and are not assessed as part of the assessment criteria. Students must avoid writing diaries of manufacture, as if submitted, they will use up both word and page count while not contributing to the evidence for assessment against the criterion. You must use the construction plan template that I will give you. I know it says that it's at the bottom of the left-hand menu part of the TSM, but I will provide you with this construction template, and you can see that in the top it has processes, equipment, scheduling, quality control, and risk assessment. You will need to give a descriptive name to the process that you're going to carry out. So for example, in the examples they give us, it says cut out technology compartments / slots in the top of the table, part A. You must identify all of the equipment that is required to complete any of the process steps. You must estimate the time required for each process. You should consider how this time is presented. For example, whether you're going to work in minutes, hours, lessons, or days. I honestly would work in minutes. I think it's your best bet. If you decide to work in lessons or days, there should be an indication of the actual time to complete the process. So you'll have to put that into minutes anyway, so it's best to just put your process time in minutes. So for scheduling, we should be using minutes. You must state how you will ensure high quality in this process. The best work for this aspect references measuring equipment, tolerances, use of go or no-go gauges, dry fit assembly, jigs, and templates where the same components are required multiple times. Here's an example of a go, no-go gauge, and you can see on this that you would definitely want to stay within that go zone, and whatever process you're doing, you would want to stay out of the no-go zone. Here's an example of a drilling jig that you might use in the top of a piece of wood. It allows you to drill the same holes every time. So anytime you're doing repeated manufacturing, you would want to use some sort of jig to make sure that you're doing the exact same thing each time. For risk assessment, you must identify any risks associated with the process or the materials used, but also state any preventative strategies that can be taken to reduce that risk. You must aim to reduce risks as effectively as possible. Together with drawing developed for Criterion C, Strand 2, the construction plan should be sufficient detail for a third party to follow and create that prototype. When you're completing your construction plan, make sure that you are not using any extended written text to address the strand. There must be no more than 10 words per cell in the construction plan. If there are any cells in the construction plan that exceed 10 words, all the words in the table will contribute to word count. The following is an extract from a high-performing construction plan. The student produces a detailed plan for the manufacture of the prototype. The 3 processes included in the extract that you're seeing are from a full construction plan for the prototype. The student completes a comprehensive and detailed plan for the manufacture of the prototype. Each process is detailed and refers to the bill of materials, meaning a third party can relate the plan to the part drawings to assist the manufacture of the prototype. The required equipment is identified, including any protective equipment, and there's a deep understanding of each process demonstrated through the quality control and risk management aspects. Quality control considers not only action the student or third-party manufacturer can take to ensure quality control, but also relates to the equipment, for example, using a new sharp cutting bit on the router, or ensuring the appropriate flow rate of the argon shield when MIG welding. The preparation of the materials and the measurable details are also considered, such as tolerances and things like that. Risk assessment considers the source of risks, the threat to risks posed to the student, and how the risk can be reduced, mitigation strategies. And the student demonstrates a deep understanding of these risks and the way to mitigate them, following understood health and safety guidelines. This is an example of a medium performing construction plan. The student produces a plan for the manufacture of the prototype. The 3 processes included below are an extract. The student provides details in each step of the process, not only considering the minimum equipment required, but also some of the peripheral equipment required to carry out the manufacture effectively. A few items are not considered, but the student demonstrates a good understanding of what is required for each action. The student also demonstrates a reasonable understanding of quality control and the risks involved in the processes. Quality control is focused on individual process consideration of the action that the student can take. The student has considered how they can implement the process based on a good understanding of how to achieve a good quality outcome. Risk assessment considers some risks and mitigation strategies, but does not always consider the source of the risk. There is no why involved. For example, when applying Danish oil, the student states, wears gloves to prevent contact between oil and skin. This lacks detail about why contact between oil and skin requires students to wear gloves. This is an example of a low-performing construction plan. The student produces an incomplete plan that contains some production details. The 3 processes included below are an extract from the full construction plan. The student uses the construction plan template. The student considers the processes but does not have a complete consideration of the equipment required, only focusing on the main pieces of equipment. This demonstrates a limited understanding of the process. Quality control is limited to generic statements with basic instructions of what to do rather than how to ensure the required quality. Risk assessment is limited to a few aspects of what could happen with no mitigation of risk. Risk assessment is generic in nature.